Hello students, in today's lecture I will discuss about Cyrus-Beck line clipping algorithm. So first we will see the difference between concave and convex polygon. Let us consider a polygon and we are taking 2 points inside the polygon. If we are connecting the points through a straight line and if the straight line has some portion outside the polygon, then the polygon is called as concave polygon, otherwise it is called as convex polygon. A polygon is called convex if the line joining any two interior points of the polygon lies completely inside the polygon. Now we have already seen Cohen-Sutherland line clipping algorithm. So the Cohen-Sutherland line clipping algorithm is for rectangular clipping window. But the Cyrus-Beck algorithm is used for non-rectangular convex region as a clipping window. So in this we can say that the clipping window is a kind of non-rectangular convex region. In this algorithm we are having a parametric equation which is defined as Pt is equals to P1 plus P2 minus P1 into T, where T is a parameter and it takes the value from 0 to 1. So 0 less than equals to T less than equals to 1. If T is equals to 0, then we can say that the value of P0 is P1, and if T is equals to 1, then the value of P1 is equals to P2. P1 is the initial point of the line segment and P2 is the final point of the line segment. Now here in the figure you can see that we are having one region which is represented by using R. Then we are taking one point that is called as boundary point, which is denoted by vector F, and we are taking one normal vector which is denoted by N, which is basically a unit vector on the edge of the clipping window. So if we take the dot product of N dot Pt minus F, and if the value is coming less than 0, then we can say that Pt is exterior to the polygon, and if the value is greater than equals to 0, we can say that it is interior, and if the value is equals to 0, then we can say that Pt is parallel to one of the boundary. So this I will explain by using some example. Now here what we are doing, we are taking the dot product of N and Pt minus F. Now I am substituting the value of Pt, and the value of Pt is P1 plus P2 minus P1 into T. So here you can see that we could have an equation like N dot P1 plus P2 minus P1 into T minus F is equals to 0. Now we are solving this equation, so we will get two terms. First is N dot P1 minus F and second is N dot P2 minus P1 dot T, which is equals to 0. Now here we will define one term which is called as weight factor, and it is defined as W is equals to P1 minus F, and another parameter we are defining which is called as distance parameter, and it is defined as D is equals to P2 minus P1. Now substituting the value of W and D in this equation, we will get W dot N is equals to D dot NT is equals to 0, and the value of T is given as minus W dot N upon D dot N, which is one of the boundary. So this equation can be generalized as T is equals to Wi dot Ni upon Di dot Ni. If the value of Di dot Ni is less than 0, we will get T upper limit, and if the value of Di dot Ni is greater than 0, then we will get T lower limit. If it is not in the range of 0 and 1, then we will ignore that value. So in the upper limit we will take the smaller value, and in the lower limit we will take the upper value. So here you can note that Pt upper and Pt lower gives the intersection points. So by using these T upper and T lower, we could able to find the intersection of the line segment with the window boundary. So now you can see here in the figure, we are having a non-rectangular clipping window and we are having a line segment whose endpoints are P1 and P2. The value of P1 is -2, 1 and the value of P2 is 6, 3. So here we will define the distance parameter d is equals to P2 minus P1, which is equals to 6, 3 minus -2, 1, and we will get it as 8, 2. Now we are taking one boundary and we are considering the boundary as V1, V2, and we are taking one fixed point and it is defined as f is equals to v1, and the coordinates here you can see that the value of x is 3 and the value of y is 0. So the value of f is equals to v1 3, 0. Then we are taking the normal vector on the window boundary v1, v2. So the normal can be defined as n is equals to 1, 1. The value of n could be 1, 1 or it could be 1, 0, 0, 1 or 0, 0. It depends on the value of x and y. Here you can see that as we are moving in this direction, the value of x is increasing as well as the value of y is increasing. So the normal is defined as n is equals to 1, 1. If the value of x is not changing and if the value of y is increasing, then it could be defined as n is equals to 0, 1. So in this way we can define the normal vector. Now W is defined as P1 minus F. So it is equals to -2, 1 -3, 0, which we will get as -5, 1, and W dot N is defined as -5, 1 dot 1, 1, which is equals to -4. So here we will take the value of D dot N and the value comes out to be 10, which says that the value is more than 0. So here we will get a lower limit. So T lower limit can be defined as minus n dot W upon n dot D, and it is equals to 0.4. Similarly, we could consider another boundary, and the another boundary is V2, V3. So the fixed point could be defined as V3 1, 4. Here we are taking this point as a fixed point and the value of x is 1 and the value of y is 4. And the normal vector is defined as n is equals to 1, 0, because you can see in the figure that here the value of x is increasing but there is no change in the value of y. So n is equals to 1, 0. So W is equals to P1 minus F, which could be solved as -2, 1 minus 1, 4, which is -3, -3, and W dot N could be defined as -3, -3 dot 1, 0, which is -3, and the value of D dot N comes out to be 8, which is again more than 0. So again we are getting the lower limit, and the value of lower limit is equals to 0.37. In a similar way, we could take other edges like V3, V4, V4, V5, V5, V6 and V6, V1. So either we could able to get the lower limit or we could able to get the upper limit. From the lower limit we are taking the highest value, and from the upper limit we are taking the lowest value. So here you can see that in the lower limit the highest value is 0.4 and in the upper limit the lowest value is 7 upon 8. Now we are substituting these values in the parametric equation and we will get the intersection point. So here initially I will start by substituting the lower limit value, that is 0.4, and I will able to get the point 1.2, 1.8, and while substituting the value of upper limit I will get 5, 2.7. So we can say that these two are these are the intersection points. So these are the intersection points of the line with the window boundary, and this portion is kept visible while the rest of the portion is kept invisible. Thank you.